What secret drifts through the dark when a stranger enters the sky? Above, the stars shine with patient indifference. They have burned for eons, their light crossing gulfs of time older than the earth itself. Each one is a silent witness watching as civilizations rise, collapse, and rise again beneath their glow. Yet even in this ancient stillness, something unexpected can arrive. A faint glimmer appears, too swift and too angled to belong to the sun's familiar family. It is not bound to our star's gravity. It does not follow the ancient loops of comets or the steady marches of planets. This shard is different. A fragment born of another star, orphaned in the interstellar dark, cast adrift between suns. Astronomers give it a name, 3I Atlas. Unlike the faithful wanderers that return with predictable rhythm, this visitor moves with unyielding purpose. A piece of frozen memory, older than the solar system, glowing faintly as it slides into our skies. It carries with it the scent of other worlds, the dust of forgotten collisions, the chemistry of alien dawns. Humanity stares upward, wondering at its silence. Is it only passing through, a vagabond slipping across the border of our sun's reach? Or does its very arrival carry intention? In its arc there is mystery, a line too clean, a path too perfect. Some wonder if we are the ones observing, or if we are the ones being observed. The fragment glides on, unblinking, as if the night itself has opened an eye. A question lingers in the stillness. When something comes from beyond the stars, do we study it, or does it study us? The discovery began in silence, as so many cosmic revelations do. A beam of light struck a detector on Earth, faint and fleeting, almost overlooked in the endless river of celestial data. It was early 2020 when the Atlas survey system in Hawaii, designed not for distant mysteries but for the protection of Earth, noticed something strange. Atlas, the asteroid terrestrial impact last alert system, scans the heavens each night, searching for objects that might one day collide with our fragile world. Yet what it found was not a threat from within, but a messenger from beyond. Astronomers studying its motion quickly realized this was no ordinary traveler. Its path was not curved into the familiar loops of the solar system. It was open, hyperbolic, a trajectory that could never be bound to the sun. The object was named 3I Atlas, the third of its kind, following in the wake of ʻOumuamua in 2017 and comet Borisov in 2019. Together they formed a pattern, rare visitors whose very presence confirmed that the space between stars is not empty, but seeded with fragments of distant worlds. The telescopes turned. The Pan-STARRS Observatory, the Very Large Telescope in Chile, smaller instruments across Europe and America, all began to watch this faint, icy ember. Data streamed in, revealing a nucleus shrouded in dust and gas, a faint halo betraying sublimation as the sun's warmth awakened its frozen surface. Some called it a comet, yet its motion remained sharper, cleaner, less predictable than those that orbit here. Questions rose quickly. Was it only ice and rock broken loose from a star system long ago? Or did its unusual precision hint at something stranger? ʻOumuamua had already unsettled astronomers with its odd acceleration and unclassifiable form. Now Atlas arrived, a new puzzle drifting across the instruments of science, daring humanity to decide whether this was coincidence or a pattern written across the stars. The discovery phase was not simply the logging of numbers and coordinates. It was a confrontation, a reminder that the solar system is not sealed, that beyond the steady clockwork of planets and moons lies an ocean of wanderers, and sometimes they come knocking. The trajectory of 3I Atlas was a revelation written in mathematics. As the data came in night after night, its path was plotted against the stars. At first it seemed like any other comet, an icy traveler stirred by the sun's pull, arcing through space on a long, graceful loop. But the numbers betrayed another truth. This was not a member of the sun's family. Its velocity, even at such distance, was far too great to be held in orbit. Its curve was not an ellipse but a hyperbola. This body was not bound to return. It had entered the solar system from the interstellar dark, and it would leave again, never to return. Astronomers knew instantly what this meant. The third interstellar object in just a handful of years. First ʻOumuamua in 2017, long and slender, accelerating as if pushed by an unseen hand. Then Borisov in 2019, a comet of alien ice venting gas and dust like a frozen refugee from another star. And now Atlas, fragmented, unstable, burning faintly as the sun's warmth stripped its fragile surface. For centuries, humanity had wondered whether such messengers might exist. Interstellar fragments were imagined in theory, the inevitable debris of planetary systems torn apart by gravity or chance. Yet in all of recorded history, none had ever been seen. Now, within the span of less than a decade, 3 had arrived. To many scientists, it was not only astonishing, it was unsettling. The shock was amplified by Atlas's strange behavior. Its brightness rose and fell unpredictably, as if the object were breaking apart. Telescopes recorded fluctuations that hinted at a fragile structure, a body crumbling under the stress of solar heating. Unlike the robust nucleus of Borisov or the mysterious shard of ʻOumuamua, Atlas seemed unstable, fragile, delicate. As it disintegrated, its fragments spread across the sky, each glowing faintly in the sun's light, like embers drifting from a dying fire. But it was the statistics that left astronomers restless. The solar system is vast, and the stars are separated by gulfs of unimaginable emptiness. Interstellar objects were expected to pass through, yes, but not often. Calculations before 2017 had suggested such encounters might be once in a million years, rare enough to belong to the language of probability, not experience. And yet here they were, not 1 but 3 in rapid succession. The scientific community wrestled with the implications. Perhaps their models had been wrong. Perhaps planetary systems shed far more debris than once thought, scattering billions of fragments into the galaxy. Each collision of planets, each disruption by a wandering star, could seed interstellar space with frozen remnants. If so, the void between stars was not empty at all, but crowded with the rubble of alien worlds. And yet the timing gnawed at the imagination. Why now? Why, after centuries of silence, would 3 messengers arrive in less than a human lifetime? Was this coincidence, or was there a deeper rhythm to the cosmos, an unseen tide carrying these fragments into the sun's domain? The comparisons to ʻOumuamua deepened the mystery. That first interstellar visitor had accelerated in ways no comet should, without the telltale jets of vapor that explained such motions. Some speculated about exotic physics, thin sheets of material pushed by starlight, or even artificial origins. Atlas, too, seemed peculiar in its fragility, breaking apart with unusual brightness patterns hinting at forces poorly understood. Each object carried its own anomaly, its own defiance of easy explanation. Shock turned to reflection. If the solar system was being visited so frequently, perhaps humanity was witnessing not exceptions, but the first glimpse of a greater truth. That the universe is restless, that planetary systems do not remain whole, but fracture, sending their children adrift into the galactic sea. That interstellar space is alive with fragments, and some will always find their way to us. Yet in the darker corners of speculation, another thought lingered. These were not only stones and ice. They were symbols. They were questions. And with each arrival they seemed to press closer, as if the cosmos itself were asking, "Are you watching? Are you listening?" The shock of 3i Atlas was not simply in its discovery. It was in its reminder that humanity's sense of isolation was fragile. That the night sky is not silent but dynamic. That the story of other worlds is not hidden in the distance of exoplanet light years alone, but written in the shards that pass briefly through our skies. For scientists, it was a puzzle of statistics and physics. For philosophers, it was an omen. For all who watched, it was a moment of disquiet wonder. 3 visitors in a row, each more mysterious than the last, each forcing the question, are we witnessing chance, or the opening chapter of a pattern yet to be understood? The numbers could not explain the unease. The mathematics could not soothe the wonder. Atlas drifted on, fragmenting under the sun, leaving behind not only dust but a deeper mystery. When the first reports of 3i Atlas reached the wider scientific community, the response was immediate. Telescopes across the world turned toward this faint and fragile messenger. Instruments designed to map galaxies and probe the early universe were suddenly tasked with studying a single wandering fragment that had come to us from the deep dark between stars. The Hubble Space Telescope was among the first to capture its ghostly form. Suspended in Earth's orbit, far above the blurring effects of atmosphere, Hubble resolved the comet's faint coma, a tenuous halo of gas and dust drifting into the void. Against the velvet black of space, Atlas appeared as a streak of dim light, not steady but trembling with irregularity. Brightness flared, dimmed, and flared again. It was as though the object could not hold itself together. Closer to Earth, the twin telescopes of Pan-STARRS in Hawaii tracked its fading glow. Their wide-field eyes, normally tasked with surveying vast regions of the sky for asteroids that might threaten our world, now narrowed their gaze. Each night brought new measurements of position, speed, and brightness. And each night, the story grew stranger. Spectroscopy offered the first clues to its nature. By splitting its light into a spectrum, scientists searched for chemical fingerprints. The results spoke of volatile ices, water, carbon dioxide, perhaps carbon monoxide, sublimating as sunlight warmed the surface. Mixed within were silicate dust grains, fragments of rock and metal that hinted at a violent past. These were the familiar elements of a comet, yet in their ratios, in their precise balance, something felt alien. The chemistry of Atlas did not match perfectly with the comets born in our own solar system. It carried echoes of different conditions, shaped under the light of another star, forged in a nursery far from the one that birthed Earth. But the greatest mystery was its unraveling. As Atlas drew closer to the sun, it began to break apart. Jets of gas erupted from its fractured surface, tearing chunks from its nucleus. Dozens of fragments were released, scattering into separate trails. Astronomers tracked them, expecting the physics to follow predictable patterns: sublimation, radiation pressure, gravitational tug. Yet the fragments behaved with a troubling freedom. Some brightened unexpectedly as though ignited from within. Others faded too quickly, as though consumed by forces more subtle than heat. The simple narrative of a comet falling apart did not fit. It was as if Atlas was revealing a more fragile architecture, perhaps hollow, perhaps fractured long before its arrival. Some speculated that it had endured countless collisions in interstellar space, weakened by ages of cosmic radiation. Others wondered if its strange disintegration reflected chemistry unlike anything familiar. Materials shaped in an environment unknown to us. Whatever the cause, the effect was haunting, a body unraveling in the presence of our star, its story dissolving before it could be fully told. Efforts turned to tracing its path backward. With the precision of mathematics, astronomers calculated its velocity and direction, attempting to rewind its journey through the galaxy. If it could be tracked far enough into the past, perhaps the system that launched it could be identified. Perhaps we could name the star whose gravity once held it. The search was painstaking. Stars themselves drift across the Milky Way, moving in great arcs around the galactic center. The farther back one traces an object's path, the more uncertain it becomes, for both fragment and stars are in constant motion, each with its own proper velocity. Still, models were run. Simulations cast Atlas backward into the void, through thousands of years, then millions, tracing a line across the galactic plane, but no origin revealed itself. The object's speed, its angle of approach, its subtle perturbations made certainty impossible. The further the models extended, the more they diverged, until its path became a haze of probabilities stretching across hundreds of potential stars. Atlas, like ʻOumuamua before it, defied identification. It was a child of no known sun, a messenger without a return address. This impossibility lingered like a shadow. Humanity had detected its chemistry, its shape, its disintegration. Yet we could not answer the most haunting question: where did it come from? The galaxy holds hundreds of billions of stars, each with planets, asteroids, and comets. Somewhere among them, perhaps hundreds of millions of years ago, an ancient collision or gravitational tug had cast Atlas into the interstellar dark. Since then, it had wandered, frozen and alone, until chance carried it through the solar system. And yet it is this chance that unsettled. For if so many fragments drift between the stars, then each one carries with it not only alien dust and chemistry, but alien history. To study Atlas was to hold, briefly, a piece of another system's story, one written long before humanity, one that may never be fully understood. The deeper the investigation went, the more profound the mystery became. Its chemistry whispered of alien birth. Its structure betrayed fragility beyond explanation. Its fragments danced with defiance against the models. Its origin lay hidden, forever beyond certainty. Atlas was not simply an interstellar comet. It was a reminder of how much remains unknown. The telescopes kept watching, capturing every flicker of light as its body dissolved into smaller and smaller shards. But the more they recorded, the answers scattered like the fragments themselves drifting into darkness. And so the scientists were left not with certainty, but with wonder. A broken traveler impossible to trace, fading from sight but not from thought. Its journey through our skies had been brief. Its meaning would linger much longer. The deeper astronomers looked at 3I Atlas, the more unsettling its story became. What had first appeared as a fragile comet, fraying under the heat of the sun, soon revealed patterns that defied easy explanation. Observatories across the world and in orbit collected light curves, records of its brightness over time. Normally, such records are steady in their rise and fall, governed by distance, rotation, and sublimation. But Atlas refused such predictability. Its glow flickered strangely, brightening and dimming with a rhythm too sharp, too irregular, as though the object were speaking in a language of light. The fluctuations carried whispers of memory. ʻOumuamua, the first interstellar visitor, had shown similar irregularities. Its brightness had varied wildly by a factor of 10, as if it were tumbling through space in an asymmetric shape. Some scientists proposed it was flat, like a sheet, its surfaces flashing sunlight as it spun. Others imagined a shard of rock, jagged and twisted, rotating chaotically. Yet in the absence of direct images, all was speculation. Atlas, though faint, repeated the riddle. Its light did not flow smoothly like a cometary plume. It shimmered, almost deliberate, almost watchful. Then came the fragmentation. As Atlas approached its closest passage to the sun, its body fractured into multiple pieces. Comets often break apart under thermal stress, releasing shards into separate trails. But in Atlas, the breakage suggested something more uncanny. The fragments seemed to split along axes that were unnervingly symmetrical, like the halves of a sphere cracking evenly. Like petals opening from a stem, the distribution was not the random scatter of chaos, but a pattern, reminiscent of design, though no one dared to speak the word aloud. Astronomers are trained in caution. The universe is vast, and nature has infinite ways of deceiving human perception. Symmetry can arise by chance, just as a tossed handful of sand may sometimes fall into orderly lines. Yet the pattern lingered in the data, resisting dismissal. Some scientists published cautious reports, noting unusual coherence in the debris field. Others speculated privately that something about its structure, perhaps internal layering or crystallization in deep space, had predisposed it to break apart in such a manner. But the suspicion of intent, though unspoken, hung in the background like a shadow. The timing made the unease deeper still. For millennia, no interstellar visitor had been seen. The night sky was unchanged, a steady vault of stars, planets, and comets bound to the sun. Then, in a single decade, 3 arrived. ʻOumuamua in 2017, Borisov in 2019, Atlas in 2020. Their arrival coincided uncannily with humanity's first steps into the wider cosmos. Satellites now circle the Earth by the tens of thousands. Probes sail beyond the edge of the solar system. Human eyes through telescopes and spacecraft now gaze deeper into the universe than ever before. And at this precise moment, fragments from other systems arrive in quick succession. Coincidence, perhaps, or a rhythm we had not yet perceived. Some wondered whether this was inevitable, that interstellar objects pass through constantly, but only now, with modern instruments, are we able to detect them. Statistical models support this. The surveys that discovered them, Pan-STARRS, Atlas, the Catalina Sky Survey, are recent inventions, scanning wide fields of the sky each night with digital precision. Perhaps the universe had always sent its messengers, and only now were we awake enough to notice. Yet others found the timing unsettling. If interstellar objects were always present, why had none been recorded in centuries of astronomical history? Why did the first 3 appear just as humanity's gaze turned outward, just as its machines began to step into interplanetary space? The human mind is shaped to see meaning in coincidence, yet here the coincidence felt too sharp, too poised. The question grew larger. Were these fragments simply the debris of alien worlds wandering aimlessly across the galaxy? Or could they serve some other purpose? Silent probes drifting seeds of observation, scattered deliberately into the dark. The speculation was not without precedent. Half a century earlier, the physicist Ronald Bracewell had proposed that advanced civilizations might send autonomous probes into interstellar space to watch, to listen, to wait for the rise of others. Such messengers need not move quickly. They could drift for millennia, powered only by patience, gathering what they could, transmitting when needed. It was a thought experiment, a distant possibility. And yet with ʻOumuamua and Atlas the idea returned. Not as fact, but as haunting suggestion. No evidence supported the claim. Each anomaly had natural explanations, however strained. ʻOumuamua's acceleration could be explained by sublimation of unseen volatiles. Borisov behaved like a normal comet, though of alien chemistry. Atlas fragmented under solar heating, fragile and weak, and yet together the pattern remained troubling. Visitors arriving in sequence, each bearing riddles rather than answers. The scientific community remained careful. To label these objects as artificial would demand extraordinary proof, and no such proof existed. Still, the whispers spread beyond the journals. Popular culture seized upon the idea. Were these rocks or watchers? Were they chaos or choreography? The flickering of Atlas's brightness fed the speculation most of all. Its variations resembled no known rotation, no familiar plume of dust. In its light curve, some saw randomness. Others saw possibility. Like a candle flickering in the wind, it seemed at times almost alive, almost intentional. To imagine it as a signal was folly. Yet the imagination of humanity is not easily constrained, and so the mystery deepened. The deeper the telescopes peered, the more questions arose. Each fragment, each flicker, each symmetry and its disintegration seemed to whisper of something greater than chance. And when set against the backdrop of timing, 3 visitors in so few years, at the dawn of humanity's spacefaring age, the whispers became louder still. Coincidence, or orchestration. The line between them was thin, fragile, blurred by the vastness of cosmic time. Yet the arrival of 3i Atlas pressed humanity into a state of reflection. What if these were not accidents but part of a larger story unfolding? What if the galaxy itself was not silent but watching? The questions hung in the air, unanswerable, heavy as the night sky itself. And in their weight, the story of Atlas shifted from discovery into something far more profound. It was no longer just a comet unraveling before our eyes. It was a mirror, reflecting the oldest of human fears and the newest of human hopes. Was it debris or design? A fragment of chance or a fragment of intent? No telescope could answer. No spectrum could decide. The fragments drifted on, fading into the void, leaving only their questions behind. When science encounters the unknown, it begins with humility. Data are gathered, models are drawn, and explanations are sought within the realm of the familiar. But sometimes what arrives resists the familiar. Sometimes the facts refuse the comfort of certainty, and speculation becomes the only bridge between knowledge and mystery. With 3i Atlas, as with ʻOumuamua before it, speculation was inevitable. What exactly was this visitor? Why did it behave so strangely? And why did its arrival seem so tightly bound to the moment humanity began to stretch beyond its own world? The first theories were natural, grounded in the ordinary violence of the cosmos. Astronomers pointed to the birth of planetary systems, when countless icy planetesimals form in the outer regions of disks around young stars. Most remain bound, circling their suns in stable orbits for billions of years, but some are cast out. Gravitational interactions with giant planets act like slingshots, flinging debris into interstellar exile. Over the lifetimes of galaxies, trillions of such fragments are scattered into the dark. Atlas, in this view, was simply one of them, an exile from a star system far away, wandering for untold ages before chance carried it through our own skies. This theory is elegant and supported by probability. If even a fraction of planet-forming systems eject material, the galaxy would indeed be seeded with countless interstellar comets. Each would drift silently, frozen reminders of worlds unseen. In such a scenario, encounters like ʻOumuamua, Borisov, and Atlas are not impossibilities but inevitabilities, detectable only now because humanity's telescopes have finally grown sharp enough to catch them. but the anomalies kept the natural explanations from resting easily. ʻOumuamua's acceleration without visible outgassing, Borisov's alien chemistry, rich in carbon monoxide, Atlas's symmetrical fragmentation and haunting flickers of brightness. Each bore a peculiarity, a thread of unease woven into its fabric. Could these simply be statistical outliers, each strange in its own way but ultimately natural? Perhaps. Yet in the repetition of anomalies, doubt took root. This opened the door to more exotic speculation. If these were not merely fragments of nature, what else could they be? Some proposed that ʻOumuamua might have been a fragment of alien technology, a thin sheet propelled by radiation pressure, a light sail drifting between the stars. The idea was most famously argued by Harvard astronomer Avi Loeb, who suggested that its unusual acceleration, combined with its flattened shape, could fit such a hypothesis. His claims drew criticism from many in the scientific community, but they sparked a wider conversation. For the first time in modern astronomy, the possibility of interstellar artifacts was discussed not only in fiction, but in scientific journals. Atlas, too, invited such speculation. Could its strange fragmentation be intentional? Could its flickering brightness be the decay of something not entirely natural? If an advanced civilization wished to seed the galaxy with watchers, probes designed to mimic comets would be ideal. Harmless in appearance, unremarkable in chemistry, easily dismissed as debris, yet capable of carrying instruments, data, or even signals hidden within fragile shells. The idea of probes scattered through space is not new. The Bracewell probe hypothesis, suggested in the 1960s, imagined autonomous machines sent to wait silently near young stars, observing until civilizations emerged. Unlike radio transmissions which vanish into the void, such probes would endure, gathering patiently. Could ʻOumuamua, Borisov, and Atlas be examples of such messengers? Not as visitors in the active sense, but as relics, drifting patiently until detected. Another speculation drew from celestial mechanics itself. Could gravitational slingshots not only scatter debris but also serve as intentional launchers? A civilization advanced enough to manipulate orbital dynamics might use the gravity wells of stars to hurl probes across the galaxy, embedding them in trajectories that appear natural. Such probes would not need engines. They would simply need patience, allowing physics to carry them over millions of years. And then came the question of timing. Why now? Why, after human eyes had gazed at the stars for millennia, did these interstellar fragments appear within a single decade? Was it coincidence, sharpened by the sudden sensitivity of modern surveys? Or was there something deeper? If they were artifacts, might they have been placed deliberately to arrive when humanity became capable of noticing them? A cosmic test, perhaps, a signal that a civilization had crossed the threshold of awareness. The possibility is speculative, perhaps even improbable. Yet the pattern resonates with human intuition. Just as seeds are planted in soil not for immediate harvest, but for growth in distant seasons, so too might fragments be scattered in the galaxy, not for instant contact, but for future recognition. When a civilization matures, it might notice them, study them, and realize it is not alone. Skeptics point out that extraordinary claims require extraordinary evidence, and in the case of Atlas, no such evidence exists. Its chemistry is consistent with cometary material. Its disintegration, though unusual, can be explained by fragility and solar stress. Its path, though untraceable to a star, is no more mysterious than any other interstellar fragment. To leap from anomalies to intelligence is a dangerous leap indeed. Yet the debate itself reveals something profound. When humanity peers into the dark and finds visitors from other systems, the imagination cannot help but stretch beyond physics. It reaches into philosophy, into myth, into the old question of whether we are truly alone, and perhaps that is the deepest significance of Atlas. Not in what it proves, but in what it suggests. Theories multiply because certainty is absent. Each visitor from beyond challenges assumptions, opening doors rather than closing them. Perhaps all three were natural debris, ejected from planetary systems in the ordinary course of cosmic evolution. If so, then their presence tells us the galaxy is rich with fragments, and that by studying them we might glimpse the building blocks of distant worlds. But if even one were more than natural, if even one carried with it the fingerprints of design, the implications would be staggering. It would mean the galaxy is not only inhabited but active. It would mean humanity's first encounter with intelligence beyond Earth was not through signals from afar, but through objects drifting silently into our skies. Science cannot yet decide. The data remain thin, the anomalies tantalizing but inconclusive. The telescopes that captured Atlas caught only glimpses before it fragmented and faded. Like ʻOumuamua, it left more questions than answers, and yet perhaps questions are the true gift. Each mystery presses the boundaries of thought. Each unexplained flicker of light, each fragment that resists prediction invites humanity to expand its vision, to imagine not only what is but what could be. Atlas, in its disintegration, became more than a comet. It became a mirror, reflecting both the precision of science and the vastness of imagination. In its trail, natural theories and exotic speculations coexist, neither disproving the other, each adding to the sense of wonder. Was it debris or design? A fragment of chance or a fragment of intent? The truth remains hidden in the silence of space. But the act of asking reveals how deeply humanity yearns to know, how ready it is to listen, and so the speculation continues as it must. For in the absence of certainty, mystery becomes the fuel of discovery. The night sky is vast, but humanity no longer watches it with naked eyes alone. It builds machines of glass, metal, and silicon, extensions of vision designed to pierce the deep. And with each new instrument, the ability to find interstellar wanderers grows sharper. The story of 3i Atlas is not only the story of a comet unraveling in sunlight. It is also the story of the tools that revealed it, and the greater machines now being built to watch for the next. In the mountains of Chile, beneath skies among the clearest on Earth, a giant is rising. The Borisov Observatory, with its 8-meter mirror and its immense digital camera, is designed to scan the entire southern sky every few nights. Where earlier surveys saw slices of heaven, Rubin will capture the whole tapestry over and over with relentless precision. Each flicker, each faint streak, each sudden intruder will be caught. When it begins operation, it will be the most powerful sentinel humanity has ever aimed at the heavens. And among its many tasks, it will almost certainly find more visitors from the interstellar dark. In orbit, the James Webb Space Telescope waits with a different eye. Where Rubin sees the dance of motion across the sky, Webb sees the faint whispers of chemistry. Its infrared instruments can dissect the light of even dim objects, revealing the signatures of ice, dust, and gas. Should another Atlas arrive, Webb could search its glow for exotic molecules, for ratios of elements that speak of alien birthplaces, for patterns of sublimation that hint at compositions unseen in our solar system. Webb does not only see, it interprets, turning faint photons into stories of origin. And still further in the future, humanity prepares not only to observe, but to meet. The European Space Agency's Comet Interceptor mission, scheduled for launch in the late 2020s, will wait at the gravitational balance point known as L2, a station on the edge of Earth's shadow. From there, it will bide its time until a fresh comet or perhaps even an interstellar visitor is discovered on approach. Then, like a hunter springing from cover, it will launch, intercepting the intruder in deep space. Its instruments will fly through the halo of dust and gas, capturing particles, imaging the nucleus, tasting the chemistry directly. For the first time, a spacecraft may not only watch an interstellar fragment from afar but touch its presence as it passes. But humanity's ambition reaches further still. If ʻOumuamua could not be explained and if Atlas left only questions, then perhaps the next visitor should not escape so easily. Proposed missions, such as the daring Project Lyra, imagine spacecraft launched in pursuit of interstellar objects, powered by solar sails or advanced propulsion, chasing down fragments as they leave the solar system. Such missions stretch technology to its limits, demanding speeds no human craft has yet achieved. But the motivation is clear: to capture the uncatchable, to study directly the messengers that pass through our skies. The symmetry is striking. At the same time, humanity speculates that ʻOumuamua might have been a light sail pushed by starlight. Humanity itself begins to build light sails of its own. The Breakthrough Starshot initiative envisions tiny probes, gram-scale spacecraft attached to ultra-thin sails, propelled to a fraction of light speed by powerful Earth-based lasers. These miniature travelers, if launched, could reach the nearest stars within a human lifetime. They would be fragile, delicate, yet swift, drifting emissaries of a young civilization echoing the very hypotheses proposed about alien messengers. In this effort, there is irony. To test whether interstellar visitors could be probes, humanity begins to create probes that could one day be interstellar visitors themselves. The line between studying and becoming blurs. Tools built for knowledge become, in their design, reflections of what we suspect in others. Each advance sharpens the paradox. By preparing to intercept interstellar objects, we acknowledge their importance. By building missions to pursue them, we admit that their presence cannot be ignored. And in these preparations lies an unspoken truth, that perhaps we are not only observers, but also the observed. For if humanity imagines scattering probes across the galaxy, hidden among comets and asteroids, how can it dismiss the possibility that others have already done so? Each plan drawn on paper, each sail unfurled in design labs, each calculation of slingshot trajectories, all serve as silent confessions. Confessions that what is possible for us is possible for them. Confessions that what we build as theory may exist in reality, long before we dreamed of it. The tools themselves are marvels. Rubens' sweeping gaze, Webb's delicate ears tuned to the faintest light, comet interceptors' waiting stance, breakthrough starshots' audacious sails. They are monuments to curiosity, instruments born of wonder and unease. Yet behind them a deeper story unfolds, the recognition that we are no longer passive inhabitants of one planet, but active participants in the cosmic stage. When ʻOumuamua slipped away beyond the reach of our instruments, it carried with it a lesson. To be ready. When Borisov streaked past, shedding the chemistry of another world, it reinforced the urgency. When Atlas crumbled in sunlight, it underscored the fragility of opportunity. Each visitor leaves a message written not in words but in absence. Be prepared, for the next will come. And so humanity builds. Not in fear but in longing, the longing to know, to touch, to stand for a moment at the threshold of the unknown and feel its breath. These tools, these telescopes, these missions, they are not just machines. They are the embodiment of a species learning to listen. In the end, the paradox remains. The more we prepare to study, the more we admit the possibility that what we study is already studying us. The thought hangs in the air, unprovable, unsettling, yet impossible to dismiss. Perhaps the flickers of Atlas were nothing more than fragile ice crumbling in sunlight. Perhaps its fragments were only shards of nature. Yet the preparations it inspired, the instruments pointed skyward, the missions planned, the sails imagined, speak of a deeper current. The current is recognition. Recognition that the night sky is not a stage of silence but a place of exchange. Recognition that by looking outward, we may one day meet something that has long looked inward. And so the tools sharpen. The sky awaits. The next visitor will come. And when it does, humanity will be ready. Not only with instruments of science, but with questions that stretch beyond science into the oldest chambers of wonder. The night sky has always been a mirror. In its depths, humanity has seen gods, omens, futures, and fears. The constellations carved from scattered stars are not patterns written by the cosmos, but projections of the human mind, seeking meaning in the vast. Now, as interstellar objects pass briefly through the solar system, the mirror turns again. And in 3i Atlas, humanity confronts both its fragility and its longing. If Atlas was nothing more than ice and dust, the mystery remains profound. For in its fragile body lay the story of another star. Its elements, its crystalline structures, its frozen chemistry, each was shaped under a sun not our own in conditions we can only imagine. To hold even a fragment of it would be to cradle the memory of another planetary system, to touch the relic of an ancient formation. The distances it traveled are unthinkable, measured not in years but in millions of years across voids where even starlight takes lifetimes to pass. To see it in our sky at all is to be reminded that space is not empty, but alive with the drifting debris of other worlds. If that were all, it would be enough. For what greater poetry exists than to know that across the gulf of stars, pieces of distant systems find their way to us, that in the dust of Atlas may lie clues to planets we will never see, to collisions and creations that played out long before Earth bore life. Even as mere debris, Atlas is a messenger of perspective, reminding us how small our solar system is, how young our civilization, how fleeting our knowledge. But if it was more than dust, then the implications deepen. If even one fragment of its mystery was deliberate, If even one anomaly speaks of design, then humanity is not alone. And if we are not alone, then perhaps the watchers have already been here. Perhaps the night sky is not only a vault of silent stars, but an ocean of signals too subtle to hear, fragments too quiet to interpret, probes disguised as stones and comets, passing by unnoticed until now. The thought is unsettling, yet it is also liberating, for to be observed is to be part of a larger story. Here lies the paradox. The closer humanity looks, the less certain it becomes. With every new instrument, every new detection, the boundary between knowledge and ignorance shifts outward. We learn more, yet certainty recedes. ʻOumuamua, Borisov, Atlas. Each brought data, each revealed secrets, and each multiplied the questions. Science thrives on such questions, but philosophy lingers in their shadows, asking not only what they are, but what they mean. Atlas reminds us of humility, that in a universe of hundreds of billions of stars, our understanding is still young, that in all our models, predictions, and equations, nature retains the power to surprise, and that sometimes the surprise is not gentle, but haunting, forcing us to confront the possibility that the cosmos is stranger, more deliberate, more inhabited than we once thought. In the quiet of reflection, Atlas becomes more than a comet. It becomes a symbol, a shard of the unknown that entered our sky not with thunder but with silence, not with answers but with questions. It slipped into our awareness like a whisper carried by the void, reminding us that even in the modern age of telescopes and data, the universe can still unsettle us with the simplest of gestures, a fragment crossing the night. And so the meditation turns inward. What if we are not only the watchers but also the watched? What if our telescopes straining upward are mirrored by other eyes, alien, ancient, patient, watching us in turn? Perhaps the fragments are not signs of chaos but signs of connection. Perhaps the cosmos is not indifferent but attentive. The possibility humbles. For whether we are alone or not, the message of Atlas is the same. We are fragile. We are temporary. We are part of a greater whole that we do not yet understand. The dust of other worlds drifts into our skies, and we can do nothing but watch as it passes, leaving us with questions that cut deeper than certainty. In the end, Atlas disintegrated, fading into fragments too small to track. Its trail dispersed into the solar wind, its nucleus lost to time. But its mystery endures, woven into the consciousness of those who saw it. Like a dream half remembered, it lingers at the edges of thought, asking still whether it was chance or intention, debris or design. The night sky remains, unbroken, endless. Stars stare down, indifferent yet constant. And somewhere beyond, in the unseen gulfs, other fragments wander still, bound for other suns, other skies, other civilizations waiting to ask the same questions. In the silence of that darkness, humanity stands at a threshold. Perhaps we are the watchers, casting our gaze outward, building our instruments, straining to hear. Or perhaps we are the watched, the subject of eyes we cannot yet perceive. In either case, the truth is the same. We are not the center. We are not the measure. We are only one part of a greater mystery unfolding across the galaxy. And in that mystery lies both our fear and our hope. For to look into the darkness and wonder is to be human, and to be human is to accept that the universe is not finished with us yet.